In this video, we focus on counting principles or counting techniques, and we'll focus mainly on permutations and combinations. So let's start with a very basic multiplication or counting principle that's called multiplication principle. And then we will introduce or discuss permutations and combinations. So multiplication principle says that if there are m ways of performing task T1 and n ways of performing task T2, then there are m times n ways of performing task T1 followed by task T2. For example, if we suppose that you have three hats, let's call them A, B, and C, and you have two coats, let's call them 1 and 2, and we will ask how many different choices of hat coat combinations do you have? Here, don't worry about combinations. I mean, how many ways of dressing or choosing hat and coat in this case. So since the first task is, for example, choosing a hat, consists of three choices, this is m, and then choosing coats, we can choose among two coats, and that's n. So the counting principle says that the number of ways of performing this, of choosing a hat and coat, is m by n. That means 3 hats times 2 coats. That will give me 6 ways of choosing hat, coat. So for example, here if we can choose hat A with the first coat, or hat A with the second coat, or we can choose hat B with the first coat, hat B with the second coat, and the third thing, hat C with the first coat and hat C with the second coat. So we have 6 different ways to choose hat and coat. So this is what the multiplication principle tells us, and actually it provides us an easy way of finding those choices. And there are very interesting way of performing this or showing this or illustrating this that depends on what's called tree diagram, and this is very powerful when we study counting principles or counting techniques and probabilities. So for example, you start with hats, you have A, B, C, so you can choose one of those 3 hats, and after choosing hats, if you choose the hat A, you can choose the coat 1 or the coat 2. If you choose hat B, you can choose coat 1 or 2, and similarly for hat C. So you have those combinations: A1, A2, B1, B2, C1, and C2. So you have 6 different ways, or you can say that we have 3 choices here if you want to count numbers, and you only have 2 choices for the codes. So 3 times 2 is 6 according to the counting principle or multiplication principle. Now another example is a coin. A coin is tossed 3 times. So this is the first time we may get head or tail, and for the second time, if we get in the first toss head, in the second toss we may get head or tail. If you get in the first toss tail, then we may get head or tail on the second toss. If you get head in the first toss and head on the second toss, the third toss can be head or tail. Similarly here, head or tail, head or tail, head or tail, and then you can make your all possible outcomes here. But we are asked to find the outcomes are head, 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 tail, and you can continue. then head, tail, head, head, tail, tail, then tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. How many outcomes? We have 4 ways. We have 8 outcomes, okay, or 8 ways to arrange those outcomes, those possible outcomes. So 8 outcomes, but here the question is that you want to use multiplication principle to determine number of possible outcomes. So if we want to use that, the multiplication principle, we ask ourselves in the first task to toss the first coin, how many possible outcomes? We only have 2. In the second toss, we only have 2 possible outcomes, either head or tail. In the third toss, we only have 2 outcomes, either head or tail. So 2 times 2 times 2 is 8. 8 ways or 8 outcomes. Okay, so this is the multiplication principle. Now let's come to permutations and combinations, and let's start with permutation. Permutation is an arrangement of a set of distinct objects in a definite order. So order is important, does matter. Order is important. But for combination, combination is an arrangement of a set of distinct objects without regard to order. Order does not matter. For any natural number n factorial, this is read n factorial. As you can see, we have this notation. N factorial is n times n minus 1 times n minus 2 up to 3 to 1. For example, 3 factorial, in this case n is a 3. It's 3 times 2 times 1, which is equal to, you can multiply here, that's 6. 4 factorial, it's 4 times 3 times 2 times 1, which is 24. 5 factorial, it's 5 times 4 times 3 times 2 times 1. We multiply by all numbers less than that number. I mean natural numbers. Multiply the number by all numbers, natural numbers smaller than that number. So we have 120 here, and so on. So that's what we mean by factorial. If you see this, that means you multiply n by all numbers less than this number until you reach 1. Now we have some given, which is a statement that we accepted for without proof. It's 0 factorial is equal to 1. And actually in mathematics, when we build some concepts, we start with some definitions. And then we build our structure or our concept based on those statements that are accepted without need to prove them. So 0 factorial is equal to 1. So let's take this as a given, and then we build our factorial notation. So 0 factorial is equal to 1. Now let's start with permutations. For permutations, we want to find number of permutations of n distinct objects taken r at a time. So the formula that we're going to use is this. We may use this notation Pn, choose r from a set of n objects. If you use a calculator, you may see this on the calculator keyboard. And now how to calculate this? We apply this formula. It's n factorial over n minus r all factorial. So this gives us the permutation. So for example, Pnn, we have n factorial over n minus r. R in this case is n. So it's the second point, or the second element. So we start with this, and then this is n, this is r. So r in this case is equal to n. So n minus n factorial. So this is n factorial over 0 factorial, but we know that 0 factorial is equal to 1, so the answer is n factorial. What about the second one? So P and n is permutation of n objects taken n at a time is n factorial. Pn1 is n factorial over, now r in this case is 1, n minus 1 factorial times n factorial over n minus 1 factorial, which is n factorial over n minus 1 factorial. Now we rewrite it this way. Now we know that if you want to simplify the numerator, n factorial is n times n minus 1 up to 2 times 1, right? So what is this? This is n minus 1 factorial. So we have n times n minus 1 factorial over n minus 1 factorial, and then you simplify to get n. Now what is permutation n comma 0? That's n factorial over n minus 0, because r in this case is 0 factorial, and that's n factorial over n factorial, which is equal to 1. Now let's take an example. For example, if we want to find permutation of 3 objects taken one at a time, that's 3, this is n, this is r, over 3 minus 1 factorial, which is 3 factorial over 2 factorial, and this is 3 times 2 times 1, this is the numerator, and the denominator is 2 times 1. Now we can cancel 2 times 1, and we get 3. So permutation 3 objects taken one at a time is equal to 3. Now let's take an example. Here in this example, we want to select a committee. So we find number of ways in which a chairman and vice chairman, secretary, and treasurer can be chosen from a committee of 8 members. So 8 is n in this case, and we choose 4 of them: chairman, vice chairman, secretary, and treasurers. That's r. We want to choose 4 out of those. Now, does order matter? Yes, because the first one will be the chairman, the second one vice chairman, the third one secretary, and the fourth one is treasurer. So order does matter. So we write P n is 8, r is 4, is equal to 8 factorial over 8 minus 4 all factorial, and then this is 8 factorial over 4 factorial. You can use the calculator, or you can just compute it by hand. It's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and then you cancel those values. If you multiply those, you get 1,680 ways of choosing those 4 officials. Now let's take another example. Here we have a student painters which specializes in painting the exterior of residential buildings, has 7 people available to be organized into 3-person and 4-person teams. So in how many ways can 3-person team performed? So how to solve this problem? Now for this problem, how many ways can 3-person team performed? This is r, and n is the 7. We have 7 people. That's the total number of people. So it's P7R. R is 3. So it's permutation, and then you multiply, you find 7 factorial over 7 minus 3 factorial, and that's 7 factorial over 4 factorial, which is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Now you can cancel those like numbers, and you get 210 ways of 3-person team performed. Now, in how many ways 4 person team can be performed. So here we have r equals 4, so we use p7. We choose or take 4 at a time, so that's 7 factorial over 7 minus 4 factorial, which is equal to 7 factorial over 3 factorial. And then you may use the calculator, or you can multiply by hand as I do here. Then you cancel 3 times 2 times 1, and you get 840 ways. Now part C, in how many ways the company organized the available people into 3 or 4 person teams. In this case, when we read the word or, that means you add. If you read the word and, that means you multiply. So here we add. So the 3 teams, a 3 person team can be performed as we did in part A. It's 2, 10, or 4 teams, 4 person teams can be formed by 840 ways, different ways, and that gives us 1050 ways. Okay. Now, sometimes in some problems, we are interested in finding the number of permutations of a set of objects in which not all of objects are distinct. Those are not all of them are distinct, or not all of them are individuals. So some of them have same property. So in this case, we deal with groups. So we have n factorial, that's the total number or the whole number or the sample size, okay, and n1 is number of objects who have certain or look alike or have certain property, and n2 number of objects who have certain property or look alike, and so on. So we find it this way: n factorial over n1 factorial times n2 factorial up to n sub n factorial. For example, if we want to find the number of permutations that can be formed from all letters of the word Atlanta. So here we have n is equal to 7, and we have for letter A we have it's repeated 3 times, and letter T it's repeated 2 times, and letter L 1 time, and letter N is 1 time. Then how many ways? It's 7 of performing permutations of can be formed from all the letters. Is 7 factorial over 3 factorial times 2 factorial times 1 factorial times 1 factorial. This is n1, this is n2, this is n3, and this is n4. Note that the sum of those n's is equal to the n, the sample size, or the total number. So as you can see, we have 3 plus 2 plus 1 plus 1, and that's equal to 7. Okay, and then you can compute this using calculator or by hand to get the final answer. So if you want to simplify it, it's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1, 2 factorial is 2 times 1, and 1 factorial is 1, and 1 factorial is 1. So we cancel 3, 2, and 1, and we get 7 times 6 times 5 times 4. Okay. Which is 048. Okay. Now combinations. Combinations here, order does not matter. So AB is the same as BA. So for this example, or for this concept, we use this formula. CNR, so this is combination of n objects taken r at a time. Sometimes we see this notation, n over r, I mean n here and r here, that's read n taken r at a time. Or using calculator, we can see this in the calculator, NCR, that means combinations for n objects taken r at a time. And in this case, we have similar formula, but we divide by r factorial. We multiply by r factorial in the denominator because we want to exclude the repetition. The AB here is the same as BA. So we don't want to write them twice. That's why we multiply by r factorial. Okay, so this is very similar to the previous formula, but we multiply the denominator by r factorial, or that means we divide by r factorial the whole expression. So here we want to determine how many ways, number of ways in which an investigation subcommittee of 4 members can be selected from Senate committee of 10 members. So here order is not important. So we just choose 4 out of 10. So that means C4, because this is N, this is R. We choose out of 10, we take 4 at a time out of a group of 10 people. Or we can write it as 10, 4, taken 4 at a time. Then we need to compute this. It's 10 factorial over 10 minus 4 factorial times 4 factorial. Okay. And that should give me the 10 factorial over 6 factorial times 4 factorial. Let's simplify more. And then divide by 6 times 5. Actually, if you look at this, we can stop here at 6 and write this as 6 factorial. And the denominator, we have 6 factorial, 4 factorial. We can cancel 6 factorial. And we have 10 times 9 times 8 times 7 over 4 factorial, which is 4 times 3 times 2 times 1. And then 8 over 4 is 2. And then 9 over 3 is 3, and 10 over 2 is 5, so we have 5 times 3 times 2 times 7. So we have 15 times 14, which is 210. So 210 ways of choosing 4 members of a subcommittee out of 10 members. Now another example, so it's very important to determine if order does matter or does not matter. So a student taking an examination is required to answer exactly 10 out of 15 questions. In how many ways can 10 questions be selected? So 10 selected out of 15, that's order does not matter, so it's combination. Out of 15 we choose 10, so 10 is R, out of 15, 15 is N. And then you use the calculator, or you can compute it using this formula. This will give you, after simplifying this, you will get 3003 ways, okay, of performing this. And as you can see, you can use the calculator, or you can do it by hand. Try to do it by hand. You have 15 times 14 times 13 times 12 times 11 times 10 factorial, and in the denominator we have 10 factorial here, times 10 factorial, and then you can simplify this, and you still need to simplify the denominator. You multiply 10 by itself by the all numbers less than this, I mean to find 10 factorial, so I recommend you to use a calculator in this case. Now in B, in how many ways can the 10 questions be selected if exactly 3 of the 5 questions of the first 5 questions must be answered? So we start with, from first 5 questions, 3 must be answered, and means multiplication. The rest of them can be the 7, because we want to solve 10 out of 15. So the first 3 should be from the first 5. We have 3 of them out of 5, the first 5 questions. So from the 5 first questions, 3 should be answered. So this is the first part. And from the rest is 10. We answer 7. As you can see, the sum of the numbers here in the top should be n, is equal to n, which is 15. And then you can use the calculator, or you can do it by hand as this way, times 10 factorial over 10 minus 7 factorial times 7 factorial. Now the first expression becomes 5 factorial over 2 factorial times 3 factorial, and the second one is 10 factorial over 3 factorial times 7 factorial. You can simplify more. 5 factorial over 5 factorial is 5 times 4 times 3 factorial, because you can stop at 3, over 2 times 2 factorial, which is 2 times 1 times 3 factorial, and you can cancel 3 factorial. So the first part gives you 20 over 2, which is equal to 10. Now the second part here is 10 times 8 times 7 factorial over 3 factorial times 7 factorial. You can cancel 7 factorial, and 3 times 3 factorial is 6. So we have 10 times 8 over 6. You can cancel, you can divide by 2. This is 3, this is 4. So we have 40 over 3. And you have 10 here. So you get, the final answer should be 1200 ways. Now the last problem here is the following problem. If we have n distinct objects arranged in a circle, for example, here we have A, B, C, D, E objects, 5 objects arranged in a circle. The number of different circular arrangements of n objects, of, for example, 5 objects, is n minus 1 factorial. For example, if you have 5 objects, 5 people, you want to see them in a circle, or circular table, or chairs around a circular table, then you need to multiply to apply this. It's 5 minus 1 factorial. This is how many arrangement, how many ways of seating of those people. For example, in the first problem, in how many ways 4 men can be seated around a table with no restrictions. So we have 4 people. This is n equals 4, and it's circular, so we apply this formula. It's 4 minus 1 factorial, which is equal to 3 factorial. That's 6. 3 times 2 times 1. And so it's 6. We have 6 ways. Okay. Why? Or if you want to understand in a different way, since this is the circular table and we have 4 chairs, you need first to start with the first chair. You have only one choice, one chair to select or to seat one of the men. So we only have one seat for the first man, and for the second man there are 3 different places, this, or this. So 3 different seats. For the third one, we only have 2 seats left, and for the last one we only have 1 seat as left. So that means we have 3 times 2 times 1, which is equal to 3 factorial. Okay, so we have, which is equal to 6 ways of arranging those peoples. Now if we want to know how many ways can 4 men and 4 women be seated around a rounded table, so we have men, women here, or men and women, And here, and we want to seat them such that guests are seated between, each guest is seated between members of the opposite sex. For example, man between two women. Okay, so we first start with one seat. For example, if we decide to choose this seat to start with, then we only have one seat. And then the rest of the people, for example, if those are men, have 3 different seats to select from or to seat in. So we have 3 times 2 times 1, which is 3 factorial. And for women we have, if we choose this seat here, we have for women either they can, the first woman can be set here, 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 or here. So she has 4 options or 4 choices. The second one has only 3 choices, and the third one has only 2 choices, and the last one has only 1 choice. That's 4 factorial. So the answer is 3 factorial times 4 factorial. Okay, and that's 3 times 2 times 1 times 4 times 3 times 2 times 1. If you multiply those, you get 144 ways. Or you can use the formula. The formula says it's n factorial times n minus 1 factorial. If you just permute among them and you have opposite sex set next to each other. So once again, let me do it again here. So we have, for example, 4 men and 4 women. So we first start by choosing one seat. For example, if I decide to choose this seat, we can seat one person. So we just write 1 here because we determined one seat. The first person only have one seat available, so one way to sit. And then the second one, if that's a man, for example, the second one has 1, 2, 3 different choices. And the third one has 2. The fourth one has 1. Okay, so this is 3 factorial times. Now, if the women have, once we determine the first seat, the first woman have 1, 2, 3, 4 choices. The second one has 3, and the third one has 2. The last one has 1. So we have 4 factorial. So 1 times 3 factorial times 4 factorial is 3 factorial times 4 factorial. And the final answer here is 144 ways.